For nearly 40 years, the most important battle in computing was fought. It was fought over a single metric: speed. Faster chips, higher clock speeds, and raw, unbridled power defined the digital age. But then, the industry hit a wall, a physical, undeniable limit. The problem wasn't performance anymore. It was electricity. For decades, our world was built on x86, the language of Windows PCs, massive enterprise servers, and gaming rigs.
Then, in 2020, Apple detonated a bomb under that foundation. Its ARM-based chip didn't just compete, it fundamentally rewrote the rules. This is detonated a BARM versus foundation, and why the future of computing may belong to the architecture that wastes the least energy. Chapter 1: The Empire of x86. To understand the future, we must look at the legacy of the past.
In 1981, the IBM PC changed everything, powered by a processor from Intel. That chip used x86 architecture. Think of architecture as the language a chip speaks. It's the instruction manual that tells a processor exactly how to execute a command. Intel and AMD built an empire. By the 2000s, nearly every laptop and server relied on x86. It seemed like an invincible standard. But deep inside that success was a hidden decay. Complexity. Decades of legacy support layered over old, unoptimized code. Imagine renovating the same house every year for 40 years. Eventually, the structure becomes bloated, inefficient, and impossible to fully map.
Chapter 2: The Brain Surgery Analogy. To see why ARM thrives, we have to grasp the difference between RISC and CISC. Chapter, the home of x86, handles complex tasks with one massive instruction. It's like telling a builder, "Make me a table," and hoping they figure it out. ARM, or RISC, breaks it down. Pick up leg, insert screw, tighten bolt. More steps, but each one is perfectly efficient.
Every unnecessary operation consumes power. Power creates heat, and heat is the enemy of modern computing. For years, we solved this by adding fans, bigger heat sinks, and more power. But we eventually hit the power wall. The Apple Silicon Shockwave. In 2020, Apple took the ultimate risk. They abandoned Intel. Analysts called it reckless. But Apple knew that their mobile ARM chips had finally evolved enough to outperform desktop giants. The M1 launch wasn't just a product release. It was a demonstration of performance per watt. Efficiency became the new speed. Suddenly, laptops were silent. They stayed cool. And they lasted an entire day on a single charge. Chapter 4: The New Battlefield. It's no longer just about your laptop. The war has moved to the cloud. Every AI query, every search, every video stream needs massive computation. Power consumption is now a global crisis. A single data center can consume as much electricity as a small city. Efficiency is no longer a perk, it's a financial and environmental necessity. Companies like Qualcomm, Amazon, and Google are now betting their infrastructure on ARM-based server chips. Remember, if two cars go 200 miles per hour, but one uses half the fuel, which one wins the future? Does this mean x86 is dead? Not at all. Intel and AMD are engineering giants. They are fighting back, becoming more efficient every day. The battle is forcing a new era of evolution. Competition is pushing both architectures to their absolute physical limits. Does this mean x86? We are seeing a convergence. The lines between mobile, desktop, and server are blurring into a single, power-conscious standard. The winner won't be the chip with the highest raw clock speed. It will be the one that extracts the most value from every single watt. The future doesn't belong to the loudest or the fastest. It belongs to the most efficient. In the age of AI, energy is no longer just a cost. It is the world's most valuable resource.